Good morning, class. I'm going to be talking to us about parent functions and also transformations of functions. The key thing we need to know is that we can actually find the list of parent functions at the beginning of our book. So if we go back to the front page, you'll see graphs of parent functions. It actually gives you key information, which we will be talking about in class. So if you want a easier, quicker reference, it's all right here. Linear, absolute value, square root, uh, the greatest integer function, quadratic, cubic, rational, exponential, logarithmic. It's all here. So it also gives you key information, domain, range, x, y, and then issues like constant, it's even, or y symmetry, things like that. So you want to, that was great. If you want to, you'll be able to find a better place to find it. Anyway, at the beginning of the book. So, nevertheless, we'll talk about it. So, linear functions, the first one we have, which is the domain is the set of all real numbers. Another way of putting this is domain. Okay, grab a different part. And as I do so, just want to let you know that that with the domain range, you should also know the interval notation. So domain, the interval is between negative infinity to infinity. And the range is likewise for linear and any polynomial function. This is our domain range, okay? The range of the function is a set of all real numbers. That's this right here. So this is our interval notation. The graph, the x-intercept, so x-int, it's just setting us up. So it's not really that you have to write it this way. But our x-intercept is negative b divided by m over 0. And then y-int is 0 comma b. So as you can see, you could just plug those in. Now, it's either key that if, is it increasing or decreasing? So what's our end, what's the end of the line going to look like? And if m is greater than 0, you're going to always be increasing, okay? So this is for a linear. And if m is less than 0, then you're always going to be decreasing, okay? That's basically the sum of, and if m is 0, it's going to be constant, okay? Okay, so that is for our linear. Now let's look at squaring. We're going to go through these decently quickly, so we'll probably finish most all of them in this first video and spend more of our time on transformation. You can always plug these in and do linear functions with them. I don't think the examples are quite as crucial in this case. Okay, identity function is just where f of x equals c, so it gives you a constant value, like this right here. Or you can think of this as y equals c, so y equals some number, that's going to be our constant. A squaring function. So what's our domain for all polynomials? Our domain is the set of all numbers, so negative infinity to infinity. What's our range? Our range is negative infinity to infinity. Okay? Is the function, this is squared, sorry. Range is not all numbers. This is the parent function, sorry. So the parent function is f of x equals x squared. So then our range is going to equal 0 to infinity. Okay. Now the reason why it's 0 to infinity is because it's all non-negative numbers. So non-negative means 0 and above. Okay, it's even, which even means if you plug in a negative, you get the same thing as if you plugged in a positive, okay? Its intercept is at 0, 0, and it's decreasing on this side of the graph, and it's increasing on this side. Okay. It has symmetry of the y-axis and a relative minimum of 0, 0. So they give us the graph. You can also draw it. It's pretty straightforward. So we'll keep moving. Okay, here's 3 different ones. What I'm going to do is I'm going to give you a minute to sit there and look at them, and then I'll go through, or not a minute, but I'll give you like a few seconds. You can look at them, write them down, and I'll move through them pretty quickly. So first things first, the domain of our cubic. So cubic equals x cubed. So we're going to have a domain of all real numbers. And our range is also going to be all real numbers because cubic is an odd function. And the deal with an odd function is that if you plug in a negative in the inside, it just flips and goes the opposite, okay? Okay, and it has is an intercept of 0, 0, and it's increasing over the interval negative infinity to infinity. So this one is actually going to be constantly increasing, okay? And then after it's increasing, we also know that it has symmetry around the origin. Okay. Square root 1. Square root is going to be characterized by a few other things. Square root can't have all real numbers because you can't plug them in. So we notice that with square root, our domain is going to be all non-negative numbers, and our range is equally going to be all non-negative numbers, okay? Then its intercept is at 0, 0, like the other ones, and it's increasing, also increasing, over its entire interval. Okay? Okay, reciprocal. Reciprocal is 1 over x. So this is a key transition point where we need to see some stuff. So when we write domain in interval notation, we're going to get open parentheses, 0, open parentheses. Now you see this open parentheses, that means we can never plug that number in right here. So we can never plug in negative infinity, we can never plug in 0, okay? This u right here, which is actually the union, it means all the numbers in both sets. So all numbers in here and all numbers in here are our domain. Everything, okay? And then our range, likewise, is going to be from negative infinity to 0, open, union, 0 to infinity, okay? Simply put, there's a gap here at 0, okay? So whenever we find something that can't fit in the domain, we're actually going to get something where we have a union with it in the middle, okay? This function is odd, has no intercepts, no int. It's decreasing actually on both its intervals. So it's decreasing from negative infinity to 0, and then also, and from 0 to infinity. Okay? And this is going to be origin symmetry. Okay? It's going to be symmetrical across the origin. Okay? And these are our three graphs right here. Give me a question. 1, 2, 3. And you can actually see it's decreasing because this goes this way, and then it goes down this way. This is always increasing because as you track it, you keep going up. Same thing. Okay, step or piecewise. So this will be our last thing, and we'll finish in 1 minute. Might actually only have 2 videos today. Well, God is willing. So the greatest integer, notice, greatest integer looks like steps. And it's written with double brackets. This means that it's the greatest integer less than the number. So less than or equal to the number. So the greatest integer is always a whole number when we hit the number. So for example, sorry about that. At -1, our greatest integer is -1. At -half, greatest integer is less than -1/2, which is -1. At 1/10, greatest integer is 0 because that's the greatest integer less than or equal to our number. Okay? So our domain is going to be all real numbers. So you say domain from -infinity to infinity. For our range, it's actually going to be the z right here. And this means integers. Okay? This is the set of all integers, okay? And double bracket z, or that double z. The graph has y-intercept and x. So y-int is at it's 0, 0, and x-int at the interval 0 to 1. Okay? It jumps 1 unit. Is it continuous? No. Okay, we'll talk about continuous another time. Okay, we'll talk about changes. Okay, next video.